Hi, pre-algebra students. So these are your notes for section 1.3, solving equations with variables on both sides. And so far we've looked at one-step, two-step, and some multi-step equations. So the difference in these equations is going to be this idea right here of collecting variables on one side of the equation. So let's take a look at example 1. If you notice, there is a variable term on the left side of the equation and on the right, which we have not seen before. So that's going to be the new part of our work today. Remember that you are not allowed to collect like terms unless they're on the same side of the equal sign. And as you can see in this equation, those two terms are on two different sides of the equal sign. So in order to collect them on the same side, we have to use an inverse operation. So since our constant is on the left, we want to try to move the 2x over to the right. So since we're subtracting 2x, our inverse operation would be to add 2x on both sides of our equation. You're going to drop down the 15 because it's still there. And following your integer rule, negative 7x plus 2x is negative 5x. And then we'll divide both sides of our equation by negative 5, leaving us with x equals negative 3. Okay, so remember these 5's cancel. A positive divided by a negative is a negative. All right, let's go ahead and check this one since it asks us to do so. So remember, in order to check, we're going to take the value we found for the variable, and we're going to plug it in place of x in the original equation in both spots. Okay, and then we're just going to evaluate using order of operations. So negative 2 times negative 3 is a positive 6. Notice how I'm paying attention to the sign that precedes the number. And then a negative times a negative is a positive over here. 15 plus 6 is 21. So since both sides equal 21, that proves that our work is correct. Okay, pause if you need to. Sorry about that. Let's go ahead and take a look at example number 2. So this time we're just adding in that extra step of using the distributive property to solve. And we've done this before where we have to distribute on both sides of the equation to simplify. So we're going to do that here as well. So first we're going to distribute negative 2 on the left-hand side. Remember, we multiply the number outside by both terms inside. So negative 2 times x is negative 2x. And remember, there's a subtraction sign in front of the 5, so it makes it negative. So negative 2 times negative 5 is positive 10. On the right-hand side, we're going to distribute 6, both of those terms inside the parentheses. So first, 6 times 2 is 12. And positive 6 times negative 1/2 is negative 3. Okay, so find your variable terms. They're here and here. And you want to collect them on one side. And it really doesn't matter which side that you choose. Okay, so looking at my terms, I'm going to choose to add both sides. That way I know that I'll get a positive value of x. Some people also like the variable term b on the left-hand side. So negative 2x plus 3x is x. We're going to drop down our plus 10. We still have 12 on the right. So as you can see, we're now is pretty simple. One equation, so we're just going to subtract on both sides. And x equals positive 2. Just remember, this time it doesn't ask you to double check, but it's always a really good idea to do that just to make sure your answer makes sense. So at this time, I would pause the video. If your teachers ask you to follow directions and complete the on your own, so it's a good idea to do that before moving on. I'm going to go ahead and keep moving and look at our next section. So this is where we look at equations that don't have one solution. These kind of equations either have no solution or infinitely many solutions. This might be new material for you that you have not seen before. So it says when solving an equation that has no solution, you're going to end up with an equation that is not true, such as 0 equals 2. That is not a true statement, and I usually like to even put a slash through my equal sign to say 0 does not equal 2. I think we need to fix this next part of the definition. So infinitely many solutions we have to correct this here, is an equation that is true for any value of the variable. So let's fix this wording here. We want to scratch out the word not because it should be true, and this is also incorrect. It's going to create a statement something like 2 equals 2, where both sides of the equation are exactly the same. So, whoops. Okay, so we have 2 examples to look at. The first one we're actually telling you, sorry about that. The first one is a no solution. So let's take a look at that. Okay, so on this one again, noticing that my variable term is here and here, I'm going to collect my variables on both sides. So you would add 4x on the left and add 4x on the right. And what you should be noticing is that it forms a zero pair on both sides. Your variable term drops out, leaving you with 3 equals -7, which I said earlier is not a true statement. Therefore, it's a no solution, which you can abbreviate as NS for no solution. Okay, and that's all you have to do. These kinds of equations do not require much work. Let's look at example 4. Okay, this time everything on the left-hand side of our equation is simplified, but on the right-hand side, we need to distribute the 4. So this one's a little tricky with the fraction work. We have to do 4 times 3 halves. So I'm going to do some scratch work over here and just remind myself that I can cross cancel. 2 goes into 4 twice, and then 2 times 3 is 6. So 4 times 3 halves, x is 6x. And then, of course, 4 times 1 is 4. So dropping down the original side, it now says 6x plus 4 equals 6x plus 4. At this point, I would subtract 6x from both sides. And what I'm left with is 4 equals 4, which is a true statement, which means it is infinitely many solutions, which notice I'm abbreviating as IMS. Okay, again, just to reinforce over here, this one created a false statement, this one creates a true statement. And then just to give you a little bit more vocabulary on this one, on the right-hand side, when both sides are exactly the same, we call that an identity. Okay, so as soon as you can see right up here that both sides of your equation are going to look exactly the same on both sides, you can prove that that's going to be an infinitely many solutions. All right, so that's it for today. Please try that on your own and have all of those ready for class tomorrow if that's what your teacher instructed you to do. And have a great night.